1970s, a pair of researchers looking into possible ways to address duodenal ulcer disease were studying the way we secrete different hormones while eating, and that led to an experiment in which they pumped a hormone called glucagon-like peptide 1, or GLP-1, extracted from pigs into pig pancreases to see what effect that would have. As it turned out, this hormone stimulated the secretion of insulin while inhibiting the secretion of glucagon. And that was notable to these researchers because folks with diabetes have too much glucagon in their bodies, which is what causes high blood sugar. The idea then was that by stoking the production of more insulin and limiting the amount of glucagon being produced, you might be able to help folks with type 2 diabetes control their symptoms. These researchers shopped around the idea of building a treatment based on this hormone a little bit in subsequent years, but didn't get much interest from the major drug companies. In 1993, though, they were able to do a study that showed that by infusing folks who have type 2 diabetes with GLP-1, they could reset their blood glucose levels back to normal within just 4 hours, which was a pretty big deal, a lot better than most other options at the time. The drug based on this hormone was approved by the FDA for medical use in the United States in 2017 under the name Semaglutide, and by 2021, it had become one of the top 100 most prescribed drugs in the country, which is saying something, as the US is awash in pharmaceutical options. Even before that approval, though, there were signs that GLP-1 receptor agonists, which is what semaglutide and other drugs based on this concept are called, might have also had some other uses. In some of the clinical trials in which they were trying to gauge how well folks with type 2 diabetes fared while using the drug, for instance, they found that many of the subjects had trouble finishing the meals they were supposed to eat, which was a problem, as having that meal was part of the process, and after they ate it, ideally the whole thing, researchers would measure their blood insulin. So keeping that controlled, that food intake, was kind of important for their results. But the subjects consistently just were not as hungry as they typically would have been. Interestingly, this realization led to a proposal by one of the original researchers to the drug company Novo Nordisk, the company that brought semaglutide to market, for another drug that would help people control their appetite and, consequently, limit food intake, perhaps serving as a means of remediating obesity, which at the time in 1998 was already becoming a big health issue of significant global concern and widespread impact. The company did not end up doing anything with the patent they went in on with that researcher, but they did pursue something along those lines a little bit later, which approached the issue with a similar underlying substance, but via a different route. And in March of 2021, the company started clinical trials for that drug, which eventually became Wegovy, using basically the same substance as semaglutide, but in a different volume, and the adult subjects in that trial lost a significant amount of weight. A few months later, in June of 2021, Wegovy was approved for use in the United States to treat adults with obesity, and then in December the following year, it was approved for use by obese teens as well. Now, Wegovy and its effects were in some ways forecasted in those trials for semaglutide when test subjects were eating less than usual while on the drug. And something similar happened here, as subjects who were being given Wegovy for weight loss purposes were showing other unanticipated but positive effects as well. Among those effects were positive cardiovascular outcomes, which Novo Nordisk then tested for specifically, noting that the drug reduces the risk of major adverse cardiovascular events like heart attacks and stroke by about 20% in obese adults. The FDA approved the drug for this purpose in March of 2024, and another study that looked into semaglutide's effect on folks with liver disease resulting from HIV found that it meaningfully reduces the severity of that disease, another unexpected win. Several earlier studies that showed positive results, and which are now being looked into on larger scales and with human subjects, include those looking into its impact on depression and suicidal ideation, its potential to reduce alcohol consumption, and the possibility that it might also help with gambling addiction and other non-substance related addictions, alongside substance-based ones like addiction to nicotine. Semaglutide seems to help with eating disorders and may help with infertility issues. It may also help with persistent inflammation, enhance autophagic activity, meaning it could help the body break down cells that don't work anymore, so new ones can grow. And it might help prevent the buildup of what's called alpha-synuclein in our brains, which is thought to maybe be a cause of or contributor to Alzheimer's and Parkinson's. There's even early evidence that GLP-1 based drugs might reduce our risk of developing some types of cancer and maybe the worst long-term sorts of COVID outcomes as well. It's a very interesting time in this space, in other words, as the more we test these things and the more people who take them, the more we learn about their effects and potential use cases. And a lot of people are using this class of drug right now. Up to 12% of the US adult population has used a GLP-1 drug at some point as of early 2024, according to research from KFF. And Novo Nordisk has been struggling to make enough of the stuff in its different manifestations branded for different purposes, as have its competitors who have launched their own copycat products, and in some cases products that up the ante with even more impressive clinical results than what the first wave of GLP-1 drugs can boast. Novo Nordisk has become Europe's most valuable company on the strength of this drug class, growing by about 230% since 2021, when it first launched Wegovy. It's now hovering at something like $500 billion in market cap. But the company has suffered a few recent stock value hits due to the 1-2 punch of patients not being able to afford the drug, which can cost more than $1,000 per month, and a dearth of production capacity, which means they've been unable to meet this drug class's perhaps understandable significant demand. What I'd like to talk about today is an aspect of the pharmaceutical industry in the United States that has generally operated under the radar, but which has recently stepped into the limelight because of this rush to get GLP-1 drugs to market and in the hands of those who want them. You're listening to Let's Know Things. I'm Colin Wright. I'm able to keep this show ad-free because of support from listeners like you. If you're finding value in what I'm doing here, consider becoming a paid supporter for the cost of a cup of coffee each month at letsknowthings.com. And as a thank you for your helping me keep this show solvent, you'll receive an additional bonus More Things episode each month. All right, let's get back to the show. In the world of pharmaceuticals, especially in the US, but in a few other countries as well, compounding refers to the practice of creating a drug on demand for a patient, usually because they need a dosage or specific composition that is not manufactured in bulk, or which is not readily available in its mass-manufactured form. So while the majority of drugs in the US and similar wealthy countries are produced on scale these days, and in a variety of common portions or doses, in some cases you might need an exact dosage that's somewhere between two other doses that are manufactured on scale by the company that makes the drug. And a pharmacist can make that specific use-sized dose for you, maybe by measuring out the right amount of drug powder into a gel cap pill, maybe by blending two substances into a single liquid that you can then take all at once. These days, the most common compounding tasks revolve around removing non-active ingredients from a drug, something in the gel cap, for instance, or a binding agent that allows the drug to be delivered in liquid form for folks that need that drug but who are allergic or otherwise sensitive to something in the final mass-produced form. A color additive, a suspension, a flavoring, something like that. This is often referred to as traditional compounding, and it can only be done by a licensed pharmacist. And while all licensed pharmacists will have at least a rudimentary understanding of how to compound custom medications, some of this kind of work is done in facilities that have compounding specific equipment on hand. Some that can do sterile work and some that can only be used for non-sterile final products. Many pharmacies have some basic tools that allow them to do things like mix flavorings into gross substances to make it more palatable to kids or pets, or to weigh and mix and divvy up medicinal powders into properly sized capsules. But some pharmacies are a lot more specialized and have far fancier tools that allow them to output more elaborate concoctions for their customers. Another role these compounding pharmacies can play, though, and in this case I'm referring to that latter type, the ones with specialized tools and machines that allow them to compound on a larger and more specialized scale if they need to, is that the FDA, the Food and Drug Administration that regulates the US drug market, can allow them to make drugs that are experiencing a shortage on the market when those who have the patent for a drug are unable to scale up fast enough and meet market demand for whatever reason. In other words, these compounding pharmacies can be given the legal go-ahead by the FDA to make and sell that drug themselves. To be clear, these pharmacies are not allowed to make the exact drug. They can make a drug with the same active ingredients, and sometimes these drugs will be quite similar to the patented version, and sometimes they'll be in a different form, an injectable rather than a powder, a capsule rather than a tablet, that sort of thing. These things are also not FDA approved, so while the FDA says it is okay for them to make and sell these products in those limited circumstances, it is not meant to be equivalent to the real deal market-approved product. It is a temporary emergency measure meant to help people who would be in a lot of pain or discomfort or even danger if they don't get a drug that they need on a regular basis because of a shortage. And that brings us to what's happening now. Novo Nordisk is experiencing a shortage of its GLP-1 inhibitor-based drugs, and the FDA gave these compounding pharmacies legal permission to make GLP-1 inhibitor-based drugs with the same active ingredients, usually in the same dosage, while this shortage persists. Consequently, there are a bunch of drugs made by compounding pharmacies being marketed all over the place, produced by existing companies like Hims and 23andMe, alongside brands like Moki and Eden and Henry Meds. Most of them selling doses equivalent to those that are sold by Novo Nordisk for something like $1,000 to $1,300 a month, but the versions sold by the compounding pharmacies are usually going for closer to $250 to $300 per month. It's been estimated, by the way, that it probably costs only about $5 to produce each of those doses, so even the compounding pharmacies selling at that dramatic cut to the sticker price are likely making money hand over fist on each of these doses, which is probably why ads for these alternative branded versions of the drug are plastered all over the internet and TV and billboards and magazines right now. The FDA does keep tabs on these compounding pharmacies, and they can shut them down if they sell unsafe products, and they can threaten to shut them down if they don't toe various lines, which is something the FDA has already done as a version of the drug that was being delivered attached to a salt-like substance, which would be dissolved in water before injecting, was not considered to be as safe as the freebase version of the drug. So the FDA put out a warning, and all the folks who were making the salt version of this substance converted their supply chains over to the freebase version, lest they lose their legal ability to sell this product type. Even with that regulatory pseudo-oversight, there have been reports of people ordering these cheap versions and getting shoddy product. One study found that those reports are probably on scale with reports about side effects experienced by people who take the Novo Nordisk version, as folks taking any version of this drug can experience some pretty gnarly side effects, but it's hard to say right now, as the drug is still relatively new and this aspect of the pharmaceutical industry is again approved but not as well regulated. So it's a buy with caution and at your own risk sort of situation, though the cost savings very well might be worth it for many people, regardless of the potential risks, whatever the nature of those risks. All of which is interesting, in part because this category of drug maker is becoming more brazen with its flogging of products, probably at least in part because this particular drug is such a cash cow and is very popular right now, and in part because it will be a little while before the patent-holding drug makers like Novo Nordisk and Eli Lilly can scale up their manufacturing capacity appropriately. So investments that these other companies make in marketing will pay off longer than they might have had this shortage been just a brief one. But it's also interesting because of what this implies about the market, as conceivably at least, a lot of potential customers for this drug will become accustomed to paying just a few $100s per month for it, rather than more than $1,000. And while that lower price is doable for the compounding pharmacies, there's a chance the Novo Nordisks of the world will not consider that reduced profit margin to be worth their time and upfront investment in developing this drug, which could lead to some weird market effects and a potential whip crack in the other direction, especially if national insurance plans don't get on board with adding this type of drug to their acceptable list. A higher sticker price paired with a lack of support from insurance companies would mean this drug remains out of reach for the majority of people who might otherwise benefit from it, and that in turn could mean a rough couple of years for Novo until they can recalibrate their expectations and/or their product catalog accordingly. That said, Novo Nordisk competitor Eli Lilly recently announced that they will be selling a version of their Wegovy competitor Zepbound, which will be sold in vials instead of in auto-injector pens, reducing their packaging costs and requiring that customers load the syringes themselves. And that new version will have a shelf price of as low as $399 per month. That is a staggering undercut of Novo's offerings. And while this is partially an attempt to address the shortage of this drug, as this lower-priced version will also be available in smaller doses, it will almost certainly also help them compete with Novo and the many compounded pharmacy offerings that are still cheaper, but not as dramatically cheaper as this name brand offering as before. There's a good chance this move by Eli Lilly is just the first of many reworks that could permanently shift the average price of this drug type, allowing the fully FDA-backed versions to compete with compounded versions, remaining a little pricier but not much, which should help them maintain market share until they can get their new manufacturing capacity online, knocking those compounding competitors out of the game entirely. Of course, there's a chance that within months or just a few years, this whole industry could shift once more, as what's generally considered to be the holy grail in this space, a pill-delivered drug that accomplishes the same or better outcomes as the injectables, is in development by pretty much everyone, and some of them already have pills in phase 2 trials. For the moment, though, the name of the game seems to be discovering new benefits of this drug type, opening it up for more use cases and thus customers, and repackaging it in different ways so that the price can go lower without fully depleting the massive profits those who are producing it, big pharma and compounding pharmacies alike, are enjoying. The book I'd like to recommend today is called The Death Cafe Movement: Exploring the Horizons of Mortality by Jack Fong. This is an interesting book. It's not a light read. It's actually more of an extended research paper put into book form, but the research looks at a movement that itself, I think, personally at least, is quite uplifting. It's about discussing death in a public forum that is very open and welcoming and friendly so that people can feel comfortable talking about any aspect of death. People who just died, their own fear of death, their fear of getting older and moving toward death, which is a subject I think all of us have thought about in different contexts and in different ways, in different circumstances throughout our lives. But the idea of being able to discuss these things in such an environment is interesting to me. And the research that's been done into the positive impact that these forums have had on the people who attend them is equally interesting, I think. Now, if any of that sounds interesting to you, consider picking up a copy of The Death Cafe Movement by Jack Fong. Let's Know Things is a listener-supported show. I don't make any money from ads, only what listeners contribute by becoming paid supporters at letsknowthings.com. If you're not in the position to become a paid supporter at the moment, consider leaving a quick review wherever you get your pods. Those help get the show in front of more people and lend a hint of credibility to independently made shows like this one. A huge thanks in advance, whatever shape your support might take.